Hello students. Today is the 7th lecture session, part 2. Topic of the lecture: classification of computer network. In this video, we will cover the following topics. By territorial prevalence. By type of functional interaction. The type of network topology. By transmission medium type. By data transfer rate. By the network models used. Conclusion. By territorial prevalence. Body area networks. MAN, body area network, a wireless network of wearable computer devices. These devices can be embedded in the body, implanted, attached to the surface of the body in a fixed position, or combined with devices that people carry in various places, pockets, on the arm, or in bags. Personal area networks. A PAN, personal area network, is a network built around a person. A tray is a computer network that is used to transfer data between devices such as computers, phones, tablets, and personal handhelds. Local area networks. LAN, local area network, provides the highest speed of information exchange between computers. A typical local area network occupies a space of 1-2 buildings. The length of local networks is about 1 kilometer. Their main purpose is to bring together users, usually one company or organization, to work together. Campus area network. Campus area network, a group of local networks that are deployed in a compact area: campus, a university, an industrial enterprise, a port, a wholesale warehouse, and so on. In this case, the network equipment, switches, routers, medium and transmission, optical fiber, copper plant, cat cables, etc. Data belongs to the tenant or owner of the campus, enterprise, university, government, and so on. Metropolitan area network. MAN, metropolitan area network, allows you to interact on smaller territorial entities and operate at medium to high speeds. They slow down data transmission less than global ones, but they can provide high-speed communication over long distances. The length of urban networks is in the range from a few kilometers to tens or hundreds of kilometers. Wide area network. 1. Wide area network allows you to organize interaction between subscribers over long distances. These networks operate at relatively low speeds and can introduce significant delays in the transmission of information. The length of global networks can be thousands of kilometers. Therefore, they are somehow integrated with networks of the country's scale. By type of functional interaction. Client-server. It is a computing or network architecture in which jobs or network load are distributed between service providers, called servers, and service customers, called clients. In fact, the client and server are software. Usually these programs are located on different computers and interact with each other through a computer network via the network protocols, but they can also be located on the same machine. A peer-to-peer network. Peer-to-peer network architecture is a steadily growing method of organizing high-level network interaction, where all network nodes have equal rights and act as suppliers and consumers of network services at the same time. The type of network topology. Network topology is the layout, pattern, or organizational hierarchy of the interconnection of network hosts, in contrast to their physical or geographic location. Typically, most diagrams describing networks are arranged by their topology. The network topology can affect throughput, but reliability is often more critical. With many technologies, such as bus-star networks, a single failure can cause the network to fail entirely. In general, the more interconnections there are, the more robust the network is, but the more expensive it is to install. Common layouts are Bus network. All nodes are connected to a common medium along this medium. This was the layout used in the original Ethernet, called base and base. This is still a common topology on the data link layer, although modern physical layer variants use point-to-point links instead. Star network. All nodes are connected to a special central node. This is the typical layout found in a wireless LAN, where each wireless client connects to the central wireless access point. Ring network. Each node is connected to its left and right neighbor node, such that all nodes are connected and that each node can reach each other node by traversing nodes left or rightwards. The Fiber Distributed Data Interface (TD) made use of such a topology. Mesh network. Each node is connected to an arbitrary number of neighbors in such a way that there is at least one traversal from any node to any other. Fully connected network. Each node is connected to every other node in the network. Tree network. Nodes are arranged hierarchically. A tree network, a star bus network, is a hybrid network topology in which star networks are interconnected via viaduct bus networks. Tree networks are hierarchical, and each node can have an arbitrary number of child nodes. By transmission medium type. Wired networks. The basis of everything, cables. All network standards define the necessary conditions and characteristics of the cable used, such as bandwidth, wave resistance, impedance, specific signal attenuation, noise immunity, and others. Wireless networks. This is a computer network based on the wireless, without the use of cabling principle, fully conforming to the standards for conventional wired networks. Radio waves of the microwave range can act as a carrier of information in such networks. By data transfer rate. Low speed, up to 10 megabits per second. Medium speed, up to 100 megabits per second. High speed, over 100 megabits per second. By the network models used. This is a model of interaction between network protocols. And protocols, in turn, are standards that determine how different programs will exchange data. OC, TX/IP. OC. An open system connection, OC, is a 7-level logical network model. The OC Open Systems Interaction Model is implemented by a group of communication protocols and rules organized into several levels. 1. At the physical level, the physical, mechanical, electrical, optical characteristics of communication lines are determined. 2. At the link layer, the rules for using the physical layer by network nodes are defined. 3. The network layer is responsible for addressing and delivering messages. 4. The transport layer controls the order in which the message components pass through. 5. The task of the session layer is to coordinate communication between two application programs running on different workstations. 6. The representation layer is used to convert data from the internal format of the computer to the transmission format. 7. The application layer is the boundary between the application program and other layers. It provides a convenient interface for communication of the user's network programs. TX/IP. Transmission Control Protocol/Internet Protocol. Founders Robert Kahn, Vinton Cerf, 1970–1974. It is based on the use of IP addresses of the form A, B, C, D, 4 numbers from 0 to 255 for any host computer on the network and packets of a fixed size containing the recipient address. Used on the Internet. More general modern name Internet Protocol Suite. The newer version IP and the older version IP differ. Another option, UDP/IP. UDP is an asynchronous transport protocol that allows the exchange of datagrams byte arrays of variable length, less reliable, but faster. TX/IP speed is not always satisfactory. Distributed hash tables, DOT, distributed hash tables and peer-to-peer, PP, networks. Peer-to-peer networks are used to optimize communication between network nodes. They have their own system of network node names and faster search for them than using TX/IP protocols. TX/IP contains 4 layers. Layer 4. Application layer. Application layer is the topmost layer of 4-layer TX/IP model. Application layer is placed on the top of the transport layer. Application layer defines TX/IP application protocols and how host programs interface with transport layer services to use the network. Application layer includes all the higher level protocols like DNS, domain naming system, ITS, hypertext transfer protocol, telnet, SHESH, ERIT, file transfer protocol, TTTTT, trivial file transfer protocol, SNOM, simple network management protocol, SAINT-P, simple mail transfer protocol, DIC, dynamic host configuration protocol, X-Windows, READ-IP, remote desktop protocol, etc. Layer 3. Transport layer. Transport layer is the third layer of the 4-layer TX/IP model. The position of the transport layer is between application layer and internet layer. The purpose of transport layer is to permit devices on the source and destination hosts to carry on a conversation. Transport layer defines the level of service and status of the connection used when transporting data. The main protocols included at transport layer are TX, Transmission Control Protocol, and UDP, User Datagram Protocol. Layer 2. Internet layer. Internet layer is the second layer of the 4-layer TX/IP model. The position of internet layer is between network access layer and transport layer. Internet layer pack data into data packets known as IP datagrams, which contain source and destination address, logical address or IP address, information that is used to forward the datagrams between hosts and across networks. The internet layer is also responsible for routing of IP datagrams. Internet layer allows hosts to insert packets into network and have them delivered to the destination, on the same network or on another remote network. At the destination side, data packets may appear in a different order than they were sent. It is the job of the higher layers to rearrange them in order to deliver them to proper network applications operating at the application layer. The main protocols included at internet layer are IP Internet Protocol, ICMP Internet Control Message Protocol, ARP Address Resolution Protocol, RARP Reverse Address Resolution Protocol, and IGAM Internet Group Management Protocol. Layer 1. Network Access Layer. Network access layer is the first layer of the 4-layer TX/IP model. Network access layer defines details of how data is physically sent through the network, including how bits are electrically or optically signaled by hardware devices that interface directly with a network medium, such as coaxial cable, optical fiber, or twisted pair copper wire. The protocols/standards included in network access layer are Ethernet, token ring, DD, X25, frame relay, etc. The most popular LAN architecture among those listed above is Ethernet. Ethernet uses an access method called CSMA/CD, carrier sense multiple access/collision detection, to access the media, when Ethernet operates in a shared media. An access method determines how a host will place data on the medium. In CSMA/CD access method, every host has equal access to the medium and can place data on the wire when the wire is free from network traffic. When a host wants to place data on the wire, it will check the wire to find whether another host is already using the medium. If there is traffic already in the medium, the host will wait, and if there is no traffic, it will place the data in the medium. But if two systems place data on the medium at the same instance, they will collide with each other, destroying the data. If the data is destroyed during transmission, the data will need to be retransmitted. After collision, each host will wait for a small interval of time, and again the data will be retransmitted. Protocol stack.
This is a hierarchically organized set of network protocols that is sufficient for organizing the interaction of nodes in the network.
Protocols work in the network at the same time, so the work of protocols should be organized so that there are no conflicts or incomplete operations. Therefore, the protocol stack is divided into hierarchically constructed levels, each of which performs a specific task: preparing, receiving, transmitting data and subsequent actions with them. Network protocol. This is a set of rules and actions, sequence of actions, that allows you to connect and exchange data between two or more devices connected to the network. Protocol. Its hypertext transfer protocol is a hypertext transfer protocol. The AIDS protocol is used when forwarding web pages between computers connected to the same network. ICT file transfer protocol is a protocol for transferring files from a special file server to a user's computer. ICT allows the subscriber to exchange binary and text files with any computer on the network. After establishing a connection with a remote computer, the user can copy a file from a remote computer to his own or copy a file from his computer to a remote one. POP Post Office Protocol is a standard mail connection protocol. POP servers handle incoming mail, and the POP protocol is designed to handle requests to receive mail from client mail programs. SINP, Simple Mail Transfer Protocol, a protocol that specifies a set of rules for sending mail. The SINP server returns either a confirmation of acceptance, an error message, or requests additional information. Telnet is a remote access protocol. Telnet allows the subscriber to work on any computer that is in the same network with him, as on his own, that is, to run programs, change the mode of operation, and so on. In practice, the capabilities are limited to the access level that is set by the administrator of the remote machine. DN is a protocol designed for deep space communication networks (ICT) that are used by NASA. DHC, Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol, a network protocol that allows computers to automatically obtain the IP address and other parameters necessary for working in a TX/IP network. This protocol works according to the client-server model. Internet Protocol (IP), routable protocol of the network layer of the TX/IP stack. It was IP that became the protocol that united individual computer networks into a worldwide network, the Internet. Network addressing is an integral part of the protocol. IP address and network mask. Each computer on the Internet has its own unique address uniform resource locator (URL). Digital addresses consist of 4 decimal integers separated by dots. Each of these numbers is in the range 0 to 255. Example: the maximum number of IP addresses that can be used in a subnet of a certain size is called a subnet mask. In terms of the ICT network, subnet mask or network mask is called a bit mask that defines which portion of the IP host address of the network refers to the network address and which is the address of the node in the network. For example, a host with an IP address of, and a subnet mask of, is on the /24 network. The address of a document on the Internet consists of the following parts. Protocol, most often AIDS for web pages or ARIT for file archives. Signs / separating the protocol from the rest of the address. Domain name or IP address, the site. Directory on the server where the file name is. Address example. It's / testado, ru / test / historia / 11 class /. Conclusion. A computer network is an association of several computers for the joint solution of information, computing, educational and other tasks.
The main purpose of computer networks is the sharing of resources and the implementation of interactive communication both within one company and outside it.
The birth of computer networks was driven by a practical need to be able to share data. A personal computer is a great tool for creating a document, preparing tables, graphics, and other types of information, but there is no way to quickly share your information with others. A local computer network is a collection of computers connected by communication lines that provides network users with the potential to share the resources of all computers.
On the other hand, simply put, a computer network is a collection of computers and various devices that provide information exchange between computers in the network without the use of any intermediate media.
Internet, a global computer network covering the entire world.
In fact, the Internet consists of many local and global networks owned by various companies and enterprises, connected by various communication lines.
Thank you for your attention. Goodbye.